Hi, in this video, we are going to continue our series on practice problems for JEE Advanced. So let's look at the first question. This says that there is a function from minus pi by 2 to pi by 2 to the set of R, which is continuous such that f of 0 is 1 and integral of 0 to pi by 3 f of t dt is equal to 0. And we have to select which statement is true. Now, if you look at the first two statements, first two options, it's like saying whether a particular equation has a root or not in a certain interval, right? So the equation here is f of x minus 3 cos 3x equals 0, whether it has a root in the interval 0 to pi by 3, or this equation fx minus 3 sin 3x equals minus 6 by pi, right? So we will tackle these first, and then there are two limit questions which involve an integral of f of t dt and a particular limit, right? So let's look at this problem one by one step at a time. So basically, the first part of it, if you want to solve this and figure out whether this has a root or not, we will define a new function called g of x. I will do this on the next screen. You should pause the video at this time and try to solve it yourself. If you don't get it, you can look at the solution. So let's try it out. We'll define a new function g of x, and g of x is defined as f of x minus 3 cos 3 of x, right? Now, the question had given us data of 0 to pi by 3 f of t dt is equal to 0 and f of 0 is equal to 1. This is what the question had given us, right? So what we'll try to do is find the integral of 0 to pi by 3 because that is the interval that we want to understand. Find the integral of gx over this interval. So it is 0 to pi by 3 f of x dx minus 3 times 0 to pi by 3 cos 3x dx. Now it is clear that this integral is clearly 0 by the given data, and this integral is also 0 because it will become sine 3x by 3, and sine 3x disappears at pi by 3 and 0. So this is 0 minus 0. So we have 0 to pi by 3 g of x dx is equal to 0. What does this mean? This means that the graph of the g function should be such that somehow the areas have to cancel out, right? Obviously, this is not accurate. The area under the graph of the g function is 0. So if there is a positive area, there must be an equal and opposite negative area somehow, right? These two areas must cancel out from 0 to pi by 3. This is just a graph that I have drawn. Obviously, the graph could have many different shapes. It could be like this also. But what is guaranteed is that the positive area is cancelled by the negative area. So that means the function g of x must cross the x-axis at least once. At least once in the interval 0 to pi by 3. Right? So therefore, g of x equals to 0. G of x is equals to 0 has at least one root in 0 to pi by 3. So this is a very nice way to figure out whether a particular equation has roots or not. We define a relevant function and we check whether the area of that function, area under the graph of the function is 0 or not. We approach the second part of the problem in a similar way. We now, for the second part, we'll define a new function h of x, which is equal to f of x minus 3 sine 3 of x plus 6 over pi. And we'll try to find the integral of h of x dx from 0 to pi by 3 again, right? So this will become 0 to pi by 3 f of x dx minus 3 times integral 0 to pi by 3 sine 3x dx plus 6 by pi into pi by 3 after integrating 6 by pi. So this part is 0, this part is minus 3 times cos 3x by 3 evaluated from 0 to pi by 3, and this part is basically plus 2. So when you do pi by 3, it is cos pi, which is minus 1 by 3 minus, it becomes cos 0 by 3. So minus 1 by 3 again. and you have a minus 3 outside plus 2. So this is clearly 2 minus 2. This is 2 plus 2, right? I have made a mistake here. When I integrate this, I have to put a minus cos 3x by 3. So this becomes a plus. So this becomes a plus. This is minus 2 plus 2. So the overall thing becomes 0. So the area under the hx graph is also 0. Therefore, hx is equal to 0 has a root in 0 to pi by 3. Because the hx graph area under the curve is equal to 0, it must cross the x-axis at least once, which means hx is equal to 0 has a root, and therefore fx minus 3 sine 3x is equal to minus 6 over pi has a root. At least one root in the interval 0 to pi by 3. Okay, so we have gotten the first two options. Now we check the limits that we have to calculate. In part 3, we have to calculate this limit x tends to 0, x multiplied by 0 to x f of t dt divided by e power 1 minus e power x square. We have to find this limit and check whether it is equal to 1 or not, right? So we'll do this limit in two parts. Here we have an x, here we have 1 minus e power x square. So what I can write it as x square by 1 minus e power x square and integral 0 to x f of t dt divided by x, right? I have basically split the limit into two separate limits. This limit we'll first evaluate. So think about it. This is basically tending to 0 and tending to 0 here. It is 0 by 0. So you can do it in many ways. The easiest way is to do L'Hospitals. Also, you could do a standard form and take minus common and x square by e power x square minus 1 and then write it as minus 1 by e power x square minus 1 by x square, right? And take the limit x tends to 0 here. This is a standard form. E power x minus 1 by x tends to 0 if x tends to 0. No, this part tends to 1 if x tends to 0. That is the standard form. So the limit here will come out to be minus 1. This part. You can also check it by L'Hospitals twice. You'll have to do 2 times differentiation to get the minus 1 limit here. And then we have to calculate this limit parallelly. So this limit, you have to do differentiation here because it is 0 by 0 form. And you'll use Newton-Leibniz formula to differentiate the integral on top. So that will become f of x times 1 minus 0 divided by 1. And limit x tends to 0 of f of x is simply f of 0, which is equal to 1 as given in the problem. So the overall limit here is minus 1 times 1, which is minus 1. So the third option is also correct, right? And finally, we look at the fourth option, which is another limit calculation, which is limit x tends to 0 sine of x times integral 0 to x f of t dt divided by x square. Now this is very obvious. It is sine x by x multiplied by integral 0 to x f of t dt divided by x. This limit tends to 1 and this limit we just now calculated was tending to 1 after differentiation. So therefore this limit overall is tending to 1, which is incorrect because the option said it was minus 1. So this concludes our problem. The key takeaway from this question for you should be how to find whether a particular equation has a solution or not in a certain interval. One method is to define a particular function which basically incorporates the equation that you need. Once you have defined that function, find the area of the area under the graph of the function over that particular interval. If the area is always positive or always negative, then obviously it cannot have a root. If the area, I mean, it could have a root, but we are not sure. But if the area is 0, we are guaranteed that it has to cross the x-axis at least once, right? Area cannot be 0 unless it's a 0 function, a constant function, or it goes up and goes down, right? So therefore, that is a nice technique to find the number of solutions for an equation. Let's look at the next question. This is a differential equation problem. So it says for any real numbers alpha and beta, let y alpha comma beta of x, where x belongs to R, be a solution of the differential equation dy by dx plus alpha y is equal to x e power beta x. We are also given that y of 1 is equal to 1. Let S be the set of y alpha beta x such that alpha beta belong to real. Basically, the S set is the set of all possible solutions of this differential equation where alpha and beta are real numbers, right? Now, the question is asking which of the following functions belong to the set S? Functions belong to set S. What is set S? Set S is the set of all such y functions which are solutions of this differential equation. And the functions that are given as options for us are f of x is equal to x square by 2 e power minus x plus e minus half e power minus x. The second option is fx is equal to minus x square by 2 e power minus x plus e plus half times e power minus x. The third option is fx is equal to e power x by 2 times x minus half plus e minus e square by 4 times e power minus x. And the fourth option is fx is equal to e power x by 2 times half minus x plus e square by 4 e power minus x. So these are the four options. These are the four possible functions. We have to check whether they satisfy the differential equation or not, right? Now, obviously, there are trick ways to solve the question. Basically, one way to solve the question would be just check the options. You should take each function, check whether y of 1 is equal to 1, and then check whether it satisfies this condition or not. But that is obviously not the correct way to solve the problem. So I would not encourage that unless you have no other options left. The correct way to solve the problem would be to actually solve the differential equation, and I will do it on the next screen. So before I do it, why don't you pause the video and try it yourself and see whether you're getting the solution or not. So let's look at our differential equation dy by dx plus e power, it was alpha y plus alpha y is equal to x e power beta x, right? This is of the standard form, linear differential equation of the standard form like this, px into y is equal to qx, right? Here, px for us is alpha and qx for us is x e power beta x. So the way to solve this equation is use the integrating factor method. So it is y times integrating factor is equal to qx times integrating factor dx, right? And the integrating factor in this case will be e power integral pfx dx. So that will be e power integral of alpha dx. So that will be e power alpha x, right? So this is my integrating factor. So now solution can be written as y times e power alpha x is equal to integral of x e power beta x times e power alpha x. So if you notice here, this is becoming x e power alpha plus beta times x dx. And this side we have y e power alpha x, right? This is my differential equation. It is pretty easy to solve this. What we will say is we'll do two separate cases. Case 1 is the easy case where alpha plus beta could be equal to 0, right? If alpha plus beta is equal to 0, this side is pretty simple. It is y e power alpha x is equal to integral of x e power 0x, so that is 1, so x dx. So that is going to be x square by 2 plus some constant. So therefore y would be equal to e power minus alpha x times x square by 2 plus c e power minus alpha x, right? This is what is coming as the y solution in the case when alpha plus beta is equal to 1, right? Now, we know that the curve y passes through the point 1 comma 1. We know that y of 1 was equal to 1. That was given in the problem itself, right? So because of that, what we can say here is y of 1 equals to 1. Put that in this equation. You get 1 is equal to e power minus alpha 1 by 2 plus c times e power minus alpha. So we get e power minus alpha into c plus half is equal to 1. So e power alpha minus half is equal to c, right? So my solution becomes y is equal to x square by 2 into e power minus alpha x plus c is e power alpha minus half and e power minus alpha x. That is my solution, right? Now, this is one of my set of solutions. It clearly depends on the value of alpha. So now, if you put different values of alpha, if you put alpha is equal to 1, what will come here? You will get y is equal to x square by 2 e power minus x plus e power e minus half, e power 1 minus half, e power minus x, right? Now, this was your option 1. If you see the previous screen, this was option 1. So we get option 1 from here, right? And this was coming under the case 1 where alpha plus beta was equal to 0. Now we solve the other case where alpha plus beta is not equal to 0. So basically we have to solve this equation y e power alpha x is equal to integral of x e power alpha plus beta times x dx, right? Right. So what we can do here is we can do a simple integration by parts here, right? So I will say this is x is my first function, and integral of this becomes e power alpha plus beta x by alpha plus beta minus integral of derivative of this is 1, and this is e power alpha plus beta x by alpha plus beta dx. So this becomes equal to x e power alpha plus beta x by alpha plus beta, and another integral of this will make it 1 by alpha plus beta whole square e power alpha plus beta x. That is my solution. And I will add a plus c constant, and I'll say y e power alpha x is equal to this. This is my solution of the differential equation that is coming. So now we also have to put y of 1 is equal to 1 here as well, right? Y of 1 is equal to 1 here as well. So if you do that, you will get 1 time e power alpha is equal to e power alpha plus beta by alpha plus beta minus e power alpha plus beta by alpha plus beta whole square plus c, right? So we get the value of c, and c is coming out to be e power alpha minus e power alpha plus beta by alpha plus beta plus e power alpha plus beta by alpha plus beta whole square. That is my constant term in the solution of this differential equation. This came from the initial conditions that were given to us in the problem, right? So finally, my final function would be when I put this e power alpha minus x here and here and here, right? And put the constant term value also. So I'll write it on the next screen. My y function is coming out to be e power beta x by alpha plus beta whole square alpha plus beta x minus 1 plus e power minus alpha x, and this is the constant, e power x minus e power alpha minus e power alpha plus beta by alpha plus beta plus e power alpha plus beta by alpha plus beta square. This is my final answer after putting c and dividing by e power alpha x, because that was there on the left hand side. You can check it yourself. This is what will come, right? Now, obviously, you have to check the options as well, which options are matching this. So I will try one case where alpha is equal to beta is equal to 1. If you try that case, you will get y is equal to e power x by 4. And here you get 2x minus 1 plus e power minus x. You get e minus e square by 2 plus e square by 4, right? If you simplify this a little bit, this can be written as e power x by 2 x minus half plus e power minus x. This becomes e minus e square by 4, right? E power minus x, it is e minus e square by 4, which is basically option C, option 3 in our initial statement. So basically, this gives us the value of our solution. These are multi-correct, multiple choice questions with multiple answers. So we get two options. And notice that we solved the differential equation under two separate cases, right? One case was alpha plus beta is 0. The other case was alpha plus beta is not 0. Because the integration is slightly different in both the situations, right? Okay. One last problem that we look at for today's session is this one. It's a coordinate geometry problem. It says let E denote the parabola y square is equal to 8x. Let P be the point minus 2 comma 4, and let Q and Q dash be two distinct points on E such that the lines PQ and PQ dash are tangents to E. Let F be the focus of E. Let F be the focus of E. Then which statement is correct? Then which statement is correct? The first statement is triangle PFQ is a right angle triangle. The second statement is triangle QPQ dash is right angled. The third statement is the distance PF is equal to 5 root 2. And lastly, F lies on the line joining Q and Q dash. Okay, so let's try to understand this particular problem. This is a standard parabola. Y square is equal to 8x. So we can draw it like this roughly. Y square is equal to 8x. So the directrix, A value here is 2. So the directrix will be x is equal to minus a. So x is equal to minus 2 line is the directrix. Focus will be 2 comma 0, right? 2 comma 0 will be the focus. So that is my F point, correct? Now notice that point P lies on the directrix -2, 4. Point P is somewhere here. And we are saying Q and Q dash are 2 points on E such that the lines PQ and PQ dash are tangents. So PQ is a tangent and PQ dash is also a tangent, right? PQ and PQ dash are tangents. So basically the point P is the intersection point of two tangents to a parabola, right? Two tangents to a parabola intersect at point P and the P lies on the directrix. P lies on directrix. So you should know by property that this angle will now be 90 degree because the locus of director circle of a parabola is the directrix line. So basically the point is that from any point on the directrix, you can draw two tangents to a parabola and they will always be perpendicular to each other. So this angle is directly 90 degree by a property. So what this means is triangle QPQ dash is definitely right angle. That is correct. And if I join this, if I join Q and Q dash, what you will also get is that QQ dash will pass through the focus. How do we get that? We can see that QQ dash is the equation of chord of contact to the parabola with respect to the point P, right? Equation of chord of contact to a parabola with respect to point P will be obtained by writing the equation of tangent to the parabola using this point. So I will say it like this. It is y1 is equal to 2ax plus x1. For a standard parabola, y square is equal to 4ax. Here y1 is equal to 4. A is 2. So this is 4 times x plus x1 is -2. So notice that this is y is equal to x minus 2. The line here is y is equal to x minus 2. And you can see that the focus F, which was 2, 0, 2, 0 satisfies this line, right? Great. So if 2, 0 satisfies this line, what we are getting is focus lies on the line joining Q and Q dash. So we are getting D option also easily. We have already gotten B option. We have gotten D option also. B option was by knowing the property of a directrix of a parabola. So from a directrix, you can draw perpendicular tangents to a parabola, right? Now, if I know that F lies on this line, now I can also find the distance PF, right? The distance PF is a simple distance formula. You can check that it is 4 square plus 4 square. So it is actually root 20. So it is 2 root 5, not 5 root 2. So this option is wrong, right? And now we have to check whether PFQ is right angled or not, right? We join P and F and we check whether PFQ is right angled or not. So that is also pretty easy. What we can do is use parametric forms to find this point and this point. Both of the points lie on a focal chord. So, and their intersection point is this, the intersection of the endpoints of the tangents there, right? So what we can do here, I just want to check the slope of PF, right? Okay, actually it is pretty easy because we know the slope of this line, right? Slope of this line is +1 because y is equal to x minus 2, right? Slope is +1. We just have to check the slope of PF, right? Let's check the slope of PF. That is 4 minus 0 by -2 minus 2. So -4. So slope is -1. So slope of PF is coming -1. Slope of this line is +1. So therefore this angle is 90. So we get this option as well, right? So there are multi-correct and options 1, 2 and 4 are correct in this situation, right? If you are not aware of the second property, you will not be able to get it very easily. It can still be done, but it will be a little more annoying. So what I would recommend is for you to go through some of the videos on my channel on parabolas. I have discussed all of these properties in great detail. If you cannot watch those videos, you should refer to SL Loney. All of these properties are in the parabola chapter, which is chapter 12 of SL Loney coordinate geometry book. That is what I would recommend for this. So that concludes today's session. We saw 3 problems for JEE Advanced relevant to JEE Advanced. In the next class also, we'll continue with more problems for JEE Advanced. So hopefully you're getting something out of these videos. Try the questions yourself before you solve them. That will help you get the most advantage from these problem solving sessions. If you like the content, please like the video and subscribe to the channel. Your support is very important to me and that helps me continue working for you, right? I'll see you next time.